Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hi everyone, welcome to Charlotte IoT. We're going to have another awesome meeting tonight, and it's going to be on time series. And David came to our office earlier today and just did an awesome presentation. It's going to totally rock. How many of you guys were here? He came like 2 years ago and did a lightning talk. Was anyone there? Yeah, Mike in the back, Kurt, a few people, Mark. So you guys already know how awesome it's going to be. And I'm really stoked. David traveled here from Raleigh, and he does a great talk. And at Charlotte IoT, we've done 90 meetings. We're almost at 100. So we'll probably do a holiday party where we celebrate 100. We'll be getting close to it. We'll probably have like 93 by then. But we'll still, it's close enough to 100. We'll have maybe beer. And we're talking about doing like a junk swap or a maker swap where everyone brings stuff from their garage. I don't know about you guys, but my wife is always like wanting me to clean out stuff. So for me, it's okay if I clean out as long as I bring home stuff too. So and everyone has really cool maker stuff. Maybe we'll do a party and have some beer, maybe at a brewery. We'll see what we can do, but that's coming up. And stand up if you're on the board or raise your hand, all the board members. The reason this group is amazing is we have a really active board and do really amazing things. And one thing you'll notice is there's a new name on the board, Leslie, and she had to leave early today, but she's helping us with getting sponsorships and also helping us get meeting content. And she's like gung-ho and really like approaching big companies to present, because we've got some good ones in town, some that are local, to present what they're doing in IoT. It's great.
That's my fault.
And our website is up, and it's in double. It's amazing. So charlotteiot.com, you can check it out. And Graham, he put this together. It has our Instagram feed. It has all kinds of like great. It's a great start of our website. So I'm really appreciative to Graham and getting this up. It's amazing. And if you one good way for everyone to communicate is on Slack. And on Meetup, after your profile, if you enter your email address, then you'll get an invite for Slack. And Slack's a great place if you have questions. You can ask some of the more experienced guys in the group. If you need help testing or any part of the project, you can send messages over Slack, and people are pretty nice on it. Tonight, I don't see David. Oh, David, I'm sorry.
That's all right.
Come on down here. So David Kaplan from the Intersect Group. He's sponsoring our meeting tonight, and he's sponsoring dinner.
Pizza. Thanks for having me. It's our second time here, and we're looking forward to learning.
Let me stand closer.
All right, sorry. Yeah, so we're looking forward to learning. Yeah, we're a full-service IT staffing firm. We do mostly application development and infrastructure-based placements, but I'll leave my business card at the bottom, and thanks for having us. Got a beer. Thanks.
Thank you, Dave. Yeah. SnapAV is hosting the venue tonight, and SnapAV is a pretty incredible company. They've recently merged in with Control4. Everyone knows who Control4 is with home automation. And Graham, who's normally on our board, he had to leave early tonight. So I'm doing the SnapAV commercial, but they're looking for embedded developers, and they're looking for JavaScript developers, and just smart people in general. And SnapAV is just a really cool company, and they're big now, especially now that they've merged in with Control 4 and have all kinds of new engineering capabilities and things like that. And every time Graham does a speech, he talks about how many millions of devices they're monitoring, and it always increases. So I'm sure they're up to many million now. Snap AV, and I'm going to do a commercial on Pratt Miller. So Pratt Miller acquired our company Logical Advantage. We started Charlotte IoT, and this is a little over a year ago. And Pratt Miller gave us a whole bunch of new capabilities around engineering, and because we have a whole hundreds of mechanical engineers, electrical engineers, hundreds of engineers. We can fabricate, we have low rate manufacturing, and so now we can build things, we can manufacture them, we can do low rate type stuff. It's pretty amazing. And we've been working on our Jumpstart Kit, and we have something that's like a springboard for new projects. And we're using the same technology that Google Nest is using with OpenThread, and we're doing simulations so that if we don't have machines and sensors in our office, we can simulate it and we can test things out before we ship them out to clients. And we're doing some really amazing things. Of course, we have over-the-air updates, and we segment our security. It's on a separate network from the client and those types of things. We're always hiring as well. So if you're awesome or you're wanting to become awesome, we're always looking for DevOps people, we're looking for developers, we're looking for web developers. Any of those types of skills we're really needing. I think we're needing PMs and BAs now too. So if you guys know people or who are awesome or want to be awesome, come talk to me. Well, actually, I always forget. David, talk to him first because he paid for dinner. And then keep us in mind too. So All Things Open is coming up, which is a really awesome conference. I've spoken at it the last several years. I forgot to submit this year, and I haven't sent a letter to ask if I could speak. It's coming up on the 14th, so it's probably too late for me. But come to this event. It's an amazing event. It's one of my favorites. And in the evening, we do IoT demo tables. And in previous years, we've had like 100 different tables of IoT goodness where you can just walk around and see what vendors have. I'm sure Influx will have a table there.
I'll be there.
Yeah, so it's a great, great event. And we have a Lunch and Learn coming up on the 22nd. It's at 12 to 1. And it's at the Launch Factory, and it's from Verizon. So I'm surprised we haven't done a meeting on 5G yet. So this meeting is on 5G, and Verizon's building out a 5G network. So come learn about that. It's going to be really good, especially for like companies like ours, Pratt Miller, who does a lot with mobility, and 5G is going to open up a lot of new opportunities for us. And on November 5th, we have a field trip. So the field trips are always super fun. This is at Inventus, and Inventus helps people make consumer products. And they've helped people with I'm just guessing, 500 patents, and they've raised like hundreds of millions of dollars for these companies. And so if you have ideas, they're a great company to talk to. Well, Inventus is going to have 3 different lightning talks. So you can learn about different aspects of like making consumer products. And plus, I'm sure we'll get a tour of the place. It's just a fun night, so you won't want to miss that. Any of the tours, the field trips, you won't want to miss. And that's November 5th. And tonight, David is in town from Raleigh. And as I mentioned earlier, he spoke at our company. And I just love David. He's amazing. And just come on up. And thank you, David, for coming.
Well, now I got to live up to all that.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe.
Mostly. How many people start collecting data and building sensors and start collecting data and then think about what they're going to do with it? It's usually the other way around, right? I'm going to say that it's much more important to start with what answers am I looking for from my data? How do I plan to get that information out before I start designing sensors and start to collect my data? Because otherwise, I may collect a whole bunch of data that I don't care about in the end, right? I may have designed sensors that are then going to stream me data that I just don't care about. And you can save yourself a lot of time by working backwards. So one of the other things that I think you really need to think about when you start designing an IoT architecture is, where am I going to collect my data? That again comes back to, what am I going to do with it? Who's going to see it? And what are they going to learn from it, right? Do I want to collect it distributed out throughout my deployment, or do I want to stream everything back to a cloud instance or a central, repository? And that comes back to how is the data used? Who's going to see it? Who needs access to which parts of the data, right? If somebody doesn't need to see the data, why should I build a dashboard for them to get access to the data, right? Think about that up front. You'll save yourself a lot of time in the end. So collecting it in the cloud is, for some, a great answer. And I understand that lots of manufacturing says, absolutely not. I am not connecting my factory floor to the big I internet. That's the dumbest thing I've ever heard. And that's a valid response to that. But if you have a high availability, basically high bandwidth, low cost network, or cost doesn't matter to you, collecting your data all in the cloud, streaming everything back to some major back end can work great, right? You can get your analysis and your visualization from anywhere. All your data's in one place. You can do everything in one place, right? But you got to be able to count on your network. If you don't have such a great network, or it's too expensive, or there's other constraints on it, collecting stuff at the edge is also a great way to go about that. It's also a way to segment your data and to reduce network costs, right? If I have an unreliable backhaul network, I have one that's only up sometimes, I've got all these other problems. I can collect at the edge. I can do collection, storage, analysis, and alerting based on data at the edge, and then I can send small bits of my data back to the data center when the network's available and when it's cheap. And I can also do both of those things at once, right? And I can collect it at the edge, and I can do my analysis there, and then I can downsample that data and send it upstream, and I can have sort of n layers of that depending on how I want to build it out, right? It distributes the collection load, it distributes the storage load, it allows you to do things, segmented things for who, again, who's going to have access to the data and what do they need to see. Right? I call this a data layer architecture, and I was actually just talking to somebody at ARM about a month ago, and she said, well, I've been calling this a data layer architecture. And I said, are you listening to my talks? Because I've been saying that for a year, right? It's how can I layer this data layer from end to end, from the edge sensor all the way back to my back end, my data lake, my cloud instance, right? Where I can collect, I can store, I can analyze, I can visualize, and I can react to my data at any point along that, right? No matter how many hops it is, I can spread it out based on who needs access to it, based on what I need to do with the data at that point. You'll notice I'm here talking about IoT, but I'm actually talking about data. And maybe a controversial point, but The IoT, I do not any longer see the IoT as a hardware and sensor problem. IoT is a data problem. And I'll tell you why I say that now. So I have some sensors up here, and I'll pass them around if y'all want to play with them. So for instance, this one. This is a temperature, humidity, visible light, infrared light, atmospheric pressure sensor. Right? So it's one device. But it's got, what did I say, temperature, humidity, pressure, visible light, and infrared light. 5 data streams coming out of it. So when you hear somebody quote numbers from like Gartner that there will be 25 billion devices online by 2025, great. That's the hardware end of it. That's the small end of it. Here, I can take it down for an hour, replace the bad bearing, and bring it back up, and my factory is only down for an hour. As opposed to next week, I wasn't paying attention to the vibrational data, or I wasn't collecting it. The bearing goes bad, it tears the machine apart, I have to shut the factory down for a week while we order the part, it gets in, and we fix the machine, right? So if you're not actually monitoring the data and doing something with it, basically in real time, the question becomes, why are you collecting it? Right? What's the point? That's, to me, the whole point of IoT, is being able to make those real-time, real-world business decisions based on incoming data. And so how you collect it, how you store it, and how much of it you get is really important. And so, again, comes back to the IoT as a data problem, not a hardware problem. I mean, yeah, at some point it's a battery problem, right? Because all these things, most of these things are going to have batteries in them, and we're going to have to replace them. But that's a whole other talk for a whole other time. So this is what I call my rational IoT architecture, and it may or may not be rational to you, but it makes sense to me. So I've got a bunch of sensors, right? And they can be Wi-Fi, they can be Bluetooth, Z-Wave, Modbus. I don't care how they're connected, right? But they're all sending streams of data in to a collection point. And the way I have typically built these is I put an edge collection device that may or may not actually be the internet router for that thing. And then I send that data back to a back-end system. Now, this part of the talk is talking about Influx 1.x. And I will tell on myself that I quit using Influx DB and the whole Influx 1.x stack about 8 months ago. And I have exclusively been using the 2.0 stack that's currently in alpha for the open source. And I'm going to do some demos and show you all of that because it's super cool stuff, and it's why I sort of gave up. But the stack that we have, I can run the telegraph data collection agent at the edge, and I can run it at pretty much any other point along the architecture. And that's high-performance data ingestion, right? I have run a telegraph agent on an OpenWRT router, which is a pretty small pretty limited device, but I can run Telegraph on it to do data collection from connected devices and then send that data back upstream to Influx. Right? I can run InfluxDB for short-term storage out at the edge, and I can run it for long-term storage back in the cloud. And I can run it on an embedded ARM device at the edge, like a Raspberry Pi or a Pine 64, or pretty much anything that I want to run out at the edge. And I can run it in the data center. The thing is, it's the same code, it's the same binary, it's the same stuff. So you don't have to have people trained in embedded deployment versus server deployment in order to deploy it across the whole data layer, right? I can use Capacitor, which is our data coprocessing engine, to generate alerts, and I can do my local alerts that are important to people that are out there at the edge, and I can generate those out at the edge, and I can generate sort of more system-wide alerts back in the data center, right? And I can use Chronograph to build dashboards, and I can build dashboards out at the edge, and I can run those dashboards on Pine 64 or Raspberry Pi, or even, a small embedded device as well. I can run the entire stack on small embedded devices. I do it all the time. I run it on a Raspberry Pi Zero. Right? And that's powerful enough to run for data collection, data storage, alerting, and dashboards. The dashboards are a little less than desirable on the Pi Zero. It's just not quite strong enough, right? But I can do all that. So what we're really good at is time series data. It's all we do, right? How many people here are using like MySQL or Postgres or something for time series data? Anybody? Yeah, we already talked about that. We're going to get you over that. How many people are using Mongo? Okay, stop doing that. I can tell you that we are something like 118 times more efficient for storage on disk than Mongo for time series data. Here's the thing. It's not just that I like Influx that I tell you to not use Mongo for your IoT or not use Postgres. It's that it boils down to using the right tool for the right job, right? Postgres, MySQL, Oracle, these relational databases are phenomenal at relational data. Data that you're going to have to correlate different tables together. You're going to update customer data. You're going to delete stuff. You're going to make changes, right? That's relational data. Get a relational database for that. Don't do that in Mongo either, right? Document data, JSON data, all this kind of stuff, right? There are document databases, JSON databases specifically for that. They're really good at it. Mongo's one of them, right? So if that's your data, use that tool. But if you're talking IoT data is time series data. It's a data point with a timestamp, and it's a never-ending stream of them. That's the thing about this being a data problem, right? Once I turn these sensors on, once you deploy your IoT sensors and you turn them on, they start streaming these multiple streams of data to you, and they're never going to shut up, ever. It's going to go on forever until they die, at which point you're going to replace them with something else that's probably going to send you more data, right? It's a never-ending stream. So use the right tool for it, for ingesting large amounts of data, for storing large amounts of data, for querying large amounts of data, right? We're 54 times more efficient at ingesting data than Mongo for time series database, for time series data. It's not even close. It's not a fair fight. This looks like a really cool dashboard, right? This is some CO2 data and some light data and temperature data, and it actually looks pretty cool, right? But I am going to, that's a super boring dashboard. It doesn't do a whole lot of stuff. So we're going to go to a better dashboard. Can you see that? Okay. So this top graph, it's got two. It says raw versus compensated CO2. How many people know about ideal gas law? Anybody? You do, because I talked to you about it today. Ideal gas law, right? So if you're measuring the concentration of a gas, you need to compensate the concentration of the gas by the temperature and the pressure, because differing temperatures and pressure affect the concentration, the measured concentration of the gas. So you need to compensate for that. And there's a standard ideal gas law calculation that's fairly straightforward to do. So that's what I'm doing up here. And I'm doing it in real time in the UI. I am not storing the ideal gas law compensated value in the database, because there's no point in doing that. I'm storing the temperature, I'm storing the pressure, and I'm storing the gas reading. That's all I need to get the answer of what's the actual compensated gas reading. This one's a little more interesting. Y'all watch the weather on TV? And they tell you it's 96 degrees, but it feels like 102? That's the heat index. How many people have ever tried to calculate a heat index? It's not fun, is it? It's ugly. It is nasty. First, you got to do one calculation, the Stedman equation, which is ugly enough. And if the Stedman equation and the temperature averaged is above 80 degrees, or actually below 80 degrees, then your answer is the Stedman equation. Simple. But if it's above 80 degrees and there's a couple of other things, you got to do something called the Rothfuss regression, and then you have to either add or subtract another calculation from it. It's horrifying. This is doing it in real time in the dashboard. I built, you probably can't see that. Can you see some of that now? So I'm gathering my humidity data in a, this is, by the way, our new query language. It's called Flux. If you used Influx DB 1 dot something, you're probably used to Influx QL. We have now moved to a new query language called Flux, and it is super powerful. You can do a whole bunch of stuff that you could never do in Influx QL. So I'm going to create a table out of my humidity values. I'm going to create another table out of my temperature values. And here's one of the cool things. I can now do math across measurements in Flux. Couldn't do that in Influx QL. So my humidity is stored in one measurement and my temperature is stored in another, and I can actually get those two values from two different measurements and I could do math with them. So that's really cool. You may not think so, but I do, because I do this stuff all the time. And I'm going to join those two tables together and make one table. And in fact, well, it's going to too much on the screen. So now I have one table with a column called temperature and a column called humidity. And the last thing I'm going to do is I'm going to call this heat index calculation that I built in a package I call environmental. And it's going to give me back a table that's got the heat index calculated. And when I go back to my dashboard, I have two lines. One tells me what the measured temperature is, 81.83, and the orange one tells me what the heat index is. And I'm doing that in real time. Couldn't do that before. I've got a whole bunch of other stuff that I'm doing. If you run a greenhouse or you grow plants, something that you might be interested in is what's called the vapor pressure deficit. It's the difference between the pressure inside the leaf and the pressure outside the leaf with the humidity and some other stuff involved. And you want to make sure that that's within a certain range. Otherwise, you end up with mold on your plants. Again, I'm calculating that in real time. And I've built a calculation that just calls vapor pressure deficit. You think heat index is a pain to calculate and is ugly? Try vapor pressure deficit. It's like 6 different equations that you then all have to pull together and do one more on the answers from all 6 of those. And I can do that in real time in the dashboard, in the query language. If y'all have questions, I don't want to kill you with PowerPoint or just boring stuff. So if you have questions, please raise a hand, stand up, shout out, whatever you want. Now, unfortunately, I'm going to have to find a way to show you this one. There we go. Because I can't show you the flux for this. Because if I do, I'm going to reveal secrets that I can't reveal. One of the things that you often want to keep along with your sensor data, your time series data, is what I call sensor metadata, right? When did you put this sensor into the field, right? Who made the sensor? Who's the manufacturer? Who owns it? Who's the customer that owns it? All this kind of stuff, right? But you're not going to store that in a time series database because it's not time series data. I'm going to store that in my relational database, like MySQL. Right here is all of my customer data for all of my sensors that are on the table here that is actually stored in a MySQL instance. And I'm able to query that from Flux. Even better, if I can scroll up so you can see it, this one, and I'll show you a little bit of the flux. I'm querying my time series data for the temperature measurement and the temperature, right? And what I end up with is a table that's got that information. It's got all the tags from that data. And one of the tags from that data is this, the sensor ID. And I'm pulling that sensor ID out of my time series query, and I'm using that to query my SQL database to get all the information about that particular sensor that's giving me that particular piece of information. So now, I can see that it's a BME 280. It's made by Bosch. I own it. It's running on an ESP32 made by Adafruit. There's the sensor ID, and the measurement that it's storing its data in is the temperature measurement. And I pulled all that out of SQL based on a query to my time series database to get information about the sensor that I was looking at. Yes?
You're registering the sensors right into your system? Is that the idea kind of thing, or?
I've got a SQL database that I made up a bunch of customers, all of whom are me, right?
Sure.
And so when I put a sensor into service, I go enter the data into a form that populates the SQL database, right?
Sure.
It tells me all the data that I need to know about that sensor.
Okay.
And the sensor, when it's writing data to the database, to the time series database, is tagging all of its data with its sensor ID, right?
Sure.
And now I'm able to go query the the data from that sensor,
Uh-huh.
pull out the sensor ID,
Yep.
go query the database to get all the service information about that sensor and pull it back in.
Sure.
Right?
Sure.
So the sensor itself is not writing to the SQL database. I could write data out to the SQL database as well. Right?
Okay.
One of the cool things about InfluxDB is that it is schema on write. And what that means is that I don't have to have a DBA go design my database and make sure I have all the fields and everything in the right place, and then I can only write those. I used to work at Oracle, and one of the jokes was, no, you can't do that. There's no field in the table for that. Right? Anything you want to do, nope, you can't do that. There's no field in the table for that. Right? Schema on write means that if I want to add a new measurement to a new value field to a measurement, I just start writing to it. And the database says, hey, new measurement field. We'll write to it. I want to add a new tag. I bring a new kind of sensor online, and I want to add a different tag to it. All right? A different way to identify it. I just start writing that tag to the database, and the database says, okay, cool, new tag. We'll just start writing that, right? And that goes all the way up to the measurement. In 2.0, I have to define two things. I have to define the organization, which is what holds all my databases, and I have to define a bucket, which is essentially my database. And that bucket can have multiple measurements in it, and those measurements can have multiple tags and fields. And once I've got the bucket defined, a sensor can say, I'm going to write to this measurement, and here are my tags, and here's my values, and the database will create that measurement, put those tags and those values in it, and then carry on. Right? So I don't have to go define that. Yes?
So if you got a lot of devices deployed in the field and you're rolling it out, some of them will have the new field and some of them won't.
Yep.
The ones that like don't have the new field, will those just come in as null, or?
If you query the database for all the sensors in that measurement, some of them will have no value in that tag, right? Which can be useful. I want to find out what the old sensors are before I rolled out the new ones, right? So I'll query everything in that measurement, but I only want to see the ones that don't have a value for that tag. That shows me all the old ones that weren't writing that tag. I'm probably not going to go back and sort of backport that and backpopulate that. That's typically, updating data is not something you typically do with a time series database. The temperature is what the temperature is. The temperature was what the temperature was. I'm not going to go back and change history, right?
How about security-wise, when you register these?
Excellent question.
Have any kind of a handshake between the two?
We do. So in the 1.x version of InfluxDB, the only security we really had was username and password, and it wasn't turned on by default. So pretty much anybody could write to your database, right?
Sure.
It had some advantages. It also had some disadvantages. The 2.0 architecture completely turns that around. Everything, security is first on by default, and second, you can't turn it off. I've tried. I've spent an inordinate amount of time trying because I wanted to be able to give some demos where I didn't have to have the security turned on. And the engineer said, good luck, we don't even know how to do it, and we built it. So you can't do that. All reads, all writes to the database require a token. And the UI will generate tokens for you, and I can adjust the granularity of that token. I can issue you a write-only token to this measurement. So you can only write data to that measurement. If you try to write to a different measurement, sorry, won't let you. I can let her have a token that allows her to read and write to any measurement, right?
Sure.
So it's really adjustable in that way. It's great. It does mean that every write to the database has to have a token with it. Luckily, so there's, how many people are Arduino programmers here? Use Arduino a bunch? Great. There's an InfluxDB library for Arduino. Used to be for 1.0 only, and of course it didn't have any security in it other than username or password because we didn't care about it. There's now a version out that supports the 2.0 version of the Influx API, and it requires a token. So you'll generate a token, and you'll put it on device, and then that device can write to the database. And you can give that device a single, unique, write-only token for the measurement that it's writing to, and then it can't go rogue on you and start writing stuff to other measurements or start reading data. If somebody gets a hold of it, it's not allowed. It only has a token to do one thing, and that's write data to that one database.
So how big is the token, and how much does that increase your network traffic to include it in every write?
It's a string about that long. It's really not.
I mean, but you're talking about IoT sensor data, right? I mean, you're talking about pretty small data to start with.
Right. So I learned this lesson the hard way.
Control your chat.
But there are two ways to write data from an end device to InfluxDB. One, I can take a reading every second, and I can write that reading out to the database every second. Super inefficient. My data gets there really quick, but super inefficient because I have to open the connection to the database, have to write the data, and then I have to tear it back down, and a second's gone by, I'm already back here, I got to do this again, right? I can also do batch writes, and that's what all of these devices are doing, and I'll hand them around if you want to play with them. They're all doing batch writes. So they are queuing up anywhere between 5 and 10 rows of data, and then they're writing it all out at once, right? So that I'm only doing the whole network plumbing setup and teardown, I'm doing it 10 times less, right? Much more efficient. It's more efficient on the network, it's more efficient on the battery, and it's actually more efficient for the database. The database prefers batch writes. It's just more efficient for it.
Sure.
Right?
What's the max sample rate then? Like, if you wanted to just total chattiness, every sample we're going to send.
See, my whole job, at least some people think, is to just break stuff.
Well,
Because I will break stuff. I was traveling in Europe, and I was slightly bored because I couldn't sleep. And so I wrote this little iPhone app that grabs all of the accelerometer data out of your iPhone. Turns out that little sucker updates really fast.
sure.
So I streamed it to an InfluxDB database. 10,000 data points a second. It was screaming.
Yeah.
Yeah, it can pump out a lot of data.
That's interesting. So if you're streaming, you're probably not using a token the whole time.
Yes, you are.
Wow.
You
Okay.
have to have a token.
Or maybe it was to open it and then somehow it
Yeah.
maintained it. Or
So under the covers, the API is all an HTTP API, right? And so it's all an HTTP. It's all over HTTP
Okay.
transport. You can do it over UDP. You can do direct UDP connections, but
Yep.
you still have to send the token. In the HTTP transport, you set an authorization token header,
Yep.
right, in the HTTP header. And then you give it your token, and as it writes it out, the database gets this in, and it just reads the header, checks for their valid
Yeah.
token,
Yep.
and it can take an unholy amount of data.
Okay.
I was sort of shocked that worked. It seized up my phone before it seized up InfluxDB. Yeah, I had to shut the phone off to get it to stop because I couldn't quit. I forgot to put a quit button on it when I first wrote it. Because I was like, let's get this working, see if it works. And I didn't put a quit button on it, and it just ran forever, and it was just seizing up my phone. So if you've used the 1.x version of InfluxDB, you've probably used Capacitor to generate alerts and do data processing. Capacitor is our data co-processing engine for InfluxDB 1.x line. 2.0, Capacitor's gone. Tick scripts are gone. It's all done in Flux. So we have this notion of tasks. And I just happen to have one here that's a gas task. And it's taking from this sensor, which writes to a measurement called K30 reader. This is a Sensair K30 CO2 sensor, costs about $100 just for the sensor. And it writes to a field called CO2, so I'm pulling that out, and I'm only interested in the last value. I'm taking that last value, I'm doing this every 4 seconds. So every 4 seconds, I get the last 4 seconds of data, I take the last value, and I'm writing it out to an MQTT broker. That thing, that giant glowing orb that you've all been wondering, why does he have this thing sitting on the table, is listening to that MQTT broker. And when it gets updated values, it knows what to do. Now, there's about a 15-second lag because, again, this is queuing up 10 rows of data, and it can only query the sensor every 2 seconds. Any faster than 2 seconds, and the sensor falls over. And you'll see what's happening. Changing color, right? So this is basically a full set of IoT data collection and alert, right? And as the value drops back down, the color changes. And if I take us all the way up to 10,000, which if we were in this room and it was 10,000, we'd all be dead, it will let us know in no uncertain terms that we'd all be dead. Because it goes red. Right? So that is using our tasks to basically run what used to be a continuous query against the database and send out an alert to MQTT so that my MQTT-aware device can do something about it. Right? Yes?
So if we wanted to send an alert to a text or someone's phone, what would be the easiest way to do it?
So I need to back up a little bit. We have 2 versions of the 2.0 that are available today. The open source version, which you can run on a Mac or a Windows laptop or a Linux box, the open source version is still in alpha. We've just released alpha 18. It's pretty solid. I wouldn't recommend doing production level stuff on it yet. We also have our Influx DB Cloud 2.0 offering. For the first time, we have a free tier. So you can go to influxdata.com and click on sign up for cloud, and you can sign up for a free cloud account. We have something that's going to be coming to open source soon, but it's available in the cloud version, which are called alerts. It's different from tasks. And there are various alert endpoints. We have things like Slack and PagerDuty and some others. So you could use PagerDuty to send a page. Unfortunately, if you're signed up for the free tier, you only have the Slack alert level. So you can only alert to Slack. So I could really annoy your Charlotte IoT with alerts if you authorize the endpoint. So that's a separate way to do alerts, and we have sort of various alert levels. If you're syslog aware, you'll recognize that there's critical, there's warning, there's error, and then there's an info, right? So there's 4 alert levels that I can send. This allows me to, using a task with an MQTT output allows me to have a little bit more control over what I do and what I send, because I'm actually sending data from the database. Actually, what I'm sending is a row of line protocol from the database. So you can see that here's my MQTT client, and you'll see about every 4 seconds a new value come in. Yes?
Do many people use Influx to transform the data and then have someone else subscribing to it, like a whole bunch of users subscribing to it after you've added your variables and your math computations and things like that to the stream?
I don't know about subscribing to it, but subscribing to it in the sense of putting a dashboard front end on it, absolutely, right? There's a bunch of different ways I can do that. I can either take my data and I can do some data transformations on it, and then I can write that transformed data back to the database. Mm-hmm. And then I can build I can build dashboards based on that transformed data, right? The other thing I can do is, as you've seen, I can do those transformations in real time in the dashboard itself. So there's a couple of ways to go about that. And you can have sort of I don't know that there's a limit on the number of subscribers to an Influx database in terms of API endpoints. Okay. This is all API driven. The dashboards are all making calls to the InfluxDB API endpoints to get their data. We have client libraries available in Go and JavaScript and a bunch of other languages so that you can hit those endpoints yourself, and you can write your own, basically, consumers of that data by writing your Flux queries to those endpoints and getting tables of data back. So if you have a custom application that you want to do something with the data, you can write a small Go program or something like that and get that data back. Right. So real quick, let me just show you. I'm going to show you how sort of quick and easy it is to build one of these databases, one of these dashboards. I'm going to have to shrink it down because I can't get it. So I'm going to look at my Telegraph database. And unfortunately, I'm not sure you can see this. I have CPU, I have disk, I have a whole bunch of stuff. Turns out I'm streaming data from a whole bunch of different places and a whole bunch of different devices to this instance, right? So I have one other, in fact, let's go to the dashboard and do this so you can see it, how bad it really is. I'm going to add a gauge. I'm going to look in the Telegraph database, and way down here, I have a measurement called VOC reader. I have a sensor that is reading the volatile organic chemicals in the air. And one of the other things it does is it reads what's called the ECO2. It's not a direct CO2 measurement. You see these sensors on Adafruit all the time. They're like 10 bucks and says, oh, you can measure your CO2 content, right? So we'll use the VOC reader, and we'll get that CO2 value. And it says 400. We'll make it go all the way up to 10,000. Where'd that go? Went all the way down here. All right, so it says 400. But I'm going to pull it all the way up here where we can compare it to some of the other values we have. There's our raw CO2 value, which it says is 933 parts per million. The ECO2 one says it's 400. ECO2 is really not so accurate. Yeah, they're cheap, but they're really not all that accurate. In fact, if you look at the data sheets for these things, they say do not use ECO2 in applications where safety is a concern. Yeah. Really? You think? So if anybody, I'll hand these around. This one, the ECO2 one, is basically the bare bones of what I've built inside all these boxes.
Hey, David.
Yes.
I'm familiar with relational databases in general, but I've never used anything like Influx. Is there like a getting started tutorial or something like that?
There are. We have tons of great tutorials and documentation for getting started. One of the really cool things about InfluxDB is that, here's the temperature, humidity, and pressure, is that it's super. So our CTO has this obsession with what he calls time to awesome. So much so that he made the company trademark the phrase time to awesome. And what he means by time to awesome is that it should take very little time for you to get to the point where you can do something like this, right? Rather than spending all of your time trying to configure the tool and get the tool working, right? That's not what tools are for. Shouldn't spend all your time on the tool, you should spend all your time getting value from the tool. So we try to make that part of it, the tool itself, super easy, so you don't have to spend a whole lot of time messing with the tool, right? And that's kind of what we do. I have a video out on our website from probably a year and a half ago, which I oddly enough entitled Time to Awesome, where I did an installation of the entire InfluxDB stack on a Linux machine, and I videoed this. I did a screen capture video, and my time to awesome from start of install to building my first dashboard was 3.5 minutes. One of the pieces of advice that I always give to people who are new speakers is don't use terms like easy, simple, obvious, right? Because for a lot of people it's not. InfluxDB is pretty easy to set up, mostly because you just have to start it and then kind of follow along. The 2.0 version, you start the binary and then you log into the web page that it tells you to open, and it leads you through setting up an organization and a bucket and a user and your first data collector, right? You can use InfluxDB to collect data on lots and lots and lots of things, not just IoT. So my wife roped me into this deal. In my infinite spare time, mostly on evenings and weekends, I take care of the Windows machines at the doctor's office that she is the practice manager for. I have hated Windows my entire life, and this has not made that any better at all. And so one of the things I did recently after a spate of problems, so if you breathe into that thing, you'll see the lights change. No, the big one, yeah, the top, was I installed our Telegraph data collection agent on all of the PCs in her office and pointed them at my InfluxDB instance. So now and then I set up alerts for things like running out of memory, running out of disk space, things like this, so that I would know what's going on before it went on. And I even called her and I said, you should probably go restart the PC at the nurse's station. She said, why? I said, because it's acting up, it's running out of memory. She said, how do you know that? I know things. I know things. I know things. I know things. And it's all because I put Telegraph on every machine in there, and so I have a graph that I can load at any time that tells me which machines are, what the memory performance is of all the machines in her office. And I can see when one spikes and is starting to run out of memory because Windows has lost its mind, and I can call her up and tell her to go restart that one. Right? Before somebody's trying to do something and one of her nurses or something has a panic attack because the PC won't let her, won't respond. We'll go fix it beforehand, right? Yes.
I've worked in industry where they were using I think it was Wonderware's Pi process book. Is that I think they're pulling data off of like PLCs. Mm-hmm. You ever do anything like that?
So most PLCs are putting data out in OPC UA format, right? And we do not have, as Influx, an OPC UA connector. However, one of our partners, Factory.io, has built an OPC UA connector that connects you to Influx for data collection. Mm-hmm. So yes, we have customers that are doing exactly that. There is a project with the Eclipse IoT, the Eclipse Foundation's IoT group, and they have an open source PLC firmware, all written in Java. And I've been working with them sort of off and on, where I'm still trying to get to the point where they can put out data straight to InfluxDB. And then you can load that firmware on your PLC, and it will spit data straight to InfluxDB. But for now, the Factory.io OPC UA connector is a great solution to that. And that allows you to just collect all your data and put it straight in the database. The other option is often you can put an MQTT gateway on a PLC.
Okay.
And Telegraph has a built-in MQTT collector that it can just listen to an MQTT broker and pull it all into the database. You can do it that way. That works real well. Yes?
So do you always use Telegraph every time you're ingesting data to Influx?
No, I don't. You can. It's very efficient. It's very fast. It allows you to distribute your data collection by having lots of little Telegraph agents around that do nothing but collect the data and send it to InfluxDB. All of these devices are writing directly to InfluxDB. They are connected to a private Wi-Fi that I'm running, and they're sending that data to a data center up in Fayetteville and then storing it there, and they're writing directly to the database. So you can do it either way.
Could you use Telegraph as like a gateway and have a whole bunch of local devices talking to it? Or?
Yep, exactly how you can do it. Great, thanks.
So where's the data actually live?
Right now, this data lives in an InfluxDB instance in an AIT data center in Fayetteville.
You have your own data center.
I have a server in a data center. If you go with InfluxDB Cloud 2.0, managed hosted service, all of that is run in an AWS instance.
Okay.
Right? And that's all done with Kubernetes, and so we can spin it up and spin it down based on usage and things like that.
Sure.
Right? So that's our managed platform. But you can run single node instances wherever you want. We build it for Linux and Mac OS. We do a reference build for Windows, but Windows is not a production environment, so we don't support Windows as a production server for InfluxDB. Yes?
So if Telegraph loses its connection to Influx, does it queue up messages or?
It has a short queue, so it will queue a little bit. But once its queue fills up, it just sort of drops data. So there's things you can do to pipeline that data. You can write to, say, Kafka and have Kafka pipeline the data for you. And we have plugins to and from Kafka so that you can do that. I believe there's a blog post where somebody wrote up doing it with Apache NiFi as well, where NiFi can detect whether or not the data link is up and writes data when the data link is up and queues it when it's down. So there are ways to do that. Telegraph's really not that smart. Telegraph is a high performance, get as much in and write as much out as I can as fast as I can. Right?
So you, give the security token to the queue effectively?
So if you don't want to put a security token on your devices,
Yeah.
you can give Telegraph the security token. And then anybody can write to Telegraph, and Telegraph uses its security token to write to the database.
That sounds.
There are, right, so
But,
do you-
I mean, you
where-
just need a different level of security to get into Telegraph, I suppose. But.
yes, yeah. And so there's a couple of different ways. You can either put the security token in plain text in the configuration file, not recommended, or you can store it as an environment variable in the shell that runs Telegraph.
Yeah.
And Telegraph will always look first for an environment variable called influx token. And if it sees influx token and it has a value, it will use that. If not, it will look in the configuration file to see if it can find an influx token, and it will use that. And if it doesn't have either of those things, then it just doesn't know what to do. You're out of luck.
Just keep storing data till you run out of room.
Not for very, actually, I don't think, I think what it will do is it will immediately try to write and it will say, it will get basically a 400, denied back. And it will continue to do that and just pollute your log files with, access denied HTTP responses.
Sure.
So, again, not recommended. Not best practice, shall we say. So you can see that it's still saying that the ECO2 is 400 and we're really at right around 1,000, 933. I will say that I take this little device to meetings with me all the time. I've read some research on CO2, and if CO2 concentration is above about 1,000 parts per million, decision making is compromised. I will also tell you that in almost every meeting room you are in, it is usually above 1,500 parts per million. We're making bad decisions, people. I gave a workshop at a conference in Spain earlier this year, and we were in a small basement room in a convention center with low ceilings and no windows and closed doors, and I am not making this up. We hit 6,500 parts per million in there. And at 6,500 parts per million, you are barely able to think straight. People are snoozing, they're falling over. If you're in a meeting and you start to feel hot and stuffy and like you can't pay attention and you're tired, that is not because it's hot. It is almost 100% guaranteed that you are over about 2,500 to 3,500 parts per million of CO2 in that room. And your brain is starting to get a little bit hypoxic from lack of oxygen and CO2 and high CO2 concentrations. And you should probably leave that meeting. Certainly don't make any critical business decisions in that meeting. They will almost certainly be wrong. And I've made a ton of them. Right? Like I said, I take this to almost all the meetings I go to now, and I just, I take my laptop and I just sit this on the table and I watch my little graph. And I see it go up and up and up. Yes?
I'm curious, what is it now?
In this room right now, it is 942 parts per million.
I guess that's why we're all awake.
Yeah.
Nice.
And we can tell because we have this nice bright blue light that everything's good.
It was red before. What does that mean?
Red is 10,000. Somebody breathed directly onto the CO2 sensor, and you expel a very large amount of CO2 with each breath, and basically redline the sensor at 10,000. So if you blow on it a little more gently, we'll see, again, I can query the sensor every 2 seconds. I'm doing 10 samples before I send it to the database. So, and there we see our spike starting. $2,950 some odd parts per million. Up to 3,400 parts per million. And then it begins to fall again.
What's next for Influx DB? You've talked a little bit about the alpha that's going on, and you've got the Amazon Web Server cloud version. What else is in the pipe you can talk about?
What we're in the process of doing right now is Influx, the open source 2.0 version is in alpha. And the reason it's in alpha is that it is not at parity in the code base with the cloud version in terms of features. And that's because we spent a significant amount of engineering effort getting the 2.0 cloud infrastructure up and running and customer ready so that customers could start purchasing data plans and using that in real time. And now a lot of the effort, aside from performance tuning and features on the cloud version, is bringing the open source up to feature parity with the cloud version, right? And once we're there, we'll probably move to beta and then GA for the 2.0, and then start moving to 2.0.1 and bug fixes and up that path. But this transition from the 1.x version to the 2.0 version was a huge, entire rewrite of almost everything, giant architectural change in how we run it in the cloud and how you query it. Flux is a new query language, right? And how you do all this sort of data stuff is new. And that's all been about a 2-year effort to bring that up. So, yes.
So if your cloud code is different from your open source code and we're leveraging your cloud service and you go out of business, like what stuff wouldn't work?
Right now, the things that are I believe that, so we just cut Alpha 18 last Thursday. And I think that the alerts and notification made it into Alpha 18. I'm not entirely certain of that. And there's a couple of other things that are in the cloud version that are, and I don't know all the details of what they are, but we're getting very close to feature parity. But they're totally different architectures, right? The way our Cloud 2.0 service runs is not just the Influx DB binary running in an Influx, in an AWS container, right? The entire Cloud 2.0 architecture is all a Kubernetes environment. We're basically running this as a serverless architecture, where as demand goes up, we spin up more components to handle the demand, and as demand goes down, we can shut some of those down, and we can expand and contract various parts of the services as needed. The Influx 2.0 is multi-tenant. So we can run a single version of Influx 2.0 and have multiple tenants on that who don't have access to each other. And we can spin up various components to make sure that everybody has the performance level that they're paying for. And this is all a Kubernetes architecture, right? My understanding is that we are also, I know that we are monitoring our cloud infrastructure using InfluxDB 2.0. My understanding is that we are also using the InfluxDB 2.0 to directly handle alerts and notifications and spinning up other Kubernetes containers to handle expanding and contracting needs. So it's kind of meta in that it monitors itself and it takes care of itself, right? Using itself. We store everything. We store everything we do in InfluxDB. We store, you name it, we're monitoring it. I should probably get our VP of product, Tim Hall, out here at some point to talk to you guys. He knows more about InfluxDB than anybody I've ever met, and can go on and on and on about the dashboards that he uses to monitor the platform itself and to monitor the cloud instance. Right? We are sort of the tool of choice for infrastructure monitoring, for DevOps infrastructure monitoring. It's what a lot of folks use to monitor their cloud infrastructure. Right? Even large database companies that make their own databases buy licenses from us to use InfluxDB to monitor their cloud infrastructure because it's all time series data and we're better at it than they are, and they make databases. Right? It's just, like I said, we only do one thing. We only do time series data. And the reason we only do one thing is because we want to be really, really, really good at something. And that's what we do, and we are really, really good at it. If you go to DB Engines and look at the ratings for time series databases, you can add up the ratings for our next 7 competitors, and they are still not up to the rating of us. We are that far out in front. And then most people don't look at database ratings to make a decision on databases, but that's just the way it is. We pay attention to that number because we like it. Other questions? I'm happy to hang around afterwards and show you, building dashboards and building queries and doing all this kind of stuff. We can write queries in real time. I know it's hard to see up here. Excuse me. because the size of the screen is not great and it's hard to see actual, writing of queries. But aside from, writing the queries yourself, we also have a query builder, as you saw, where I just went and I clicked on this and I clicked on this and I clicked on this and I clicked on this, and I had a gauge that had my CO2 concentration in it. Right? And I could go back and look at I can go into the script editor, and what do you know? It built a Flux script for me, right? But I didn't have to write any Flux to build that. I was just able to select the data I wanted. And if I really wanted, there's a whole bunch of functions down here that I could add in there, so I could do a whole bunch of math stuff with that value if I wanted as well. Right? And there is derivatives and histograms and Holt Winters. It just goes on and on and on and on. Yes?
So what percentage of people use the open source version versus the cloud version?
I don't know the percentage, but so one of the things we track is the number of running InfluxDB instances in the world. When you download InfluxDB, there is a flag in the configuration file that allows it to basically phone home. And you can turn that off. We don't care. But if you don't turn it off, it tells us that it's running. And we have over 200,000 instances of InfluxDB running around the world that we know of. People that don't turn it off or don't have it behind a firewall where it can't get out, right? And I don't know the number of cloud customers that we have right now. For Cloud 2.0, it's fairly small. We just went with general availability of our cloud, I think it was 2 weeks ago. Right? We had people, a fair number of customers signed up for the beta and trying it out. But in terms of paying customers on the cloud, I just don't know the numbers because I don't do that. So that's not my thing. We have a very large number of Cloud 1.0 customers, people that are using our InfluxDB 1.0 version running in our managed cloud service. It is true that if you are running InfluxDB 1.7 or greater, you can write your queries in Flux. InfluxDB 1.7 is now Flux aware. You have to go into the configuration file and turn the Flux engine on, but then you can query the 1.7 database with Flux. So if you are running 1.7 or you don't want to play with the alpha, but you still want to be able to write your queries in Flux, you can go in and turn the Flux engine on, and then you can write queries to the 1.7.x version of the database in Flux. And you can do that. That is available today. Yes?
Question, going all the way back to the data layer architecture.
Mm-hmm.
Is there a process by which you can, downsample that data, send that to a centralized engine, using a reporting engine at a centralized level, reach back out for detailed data?
I don't necessarily know about the reaching back out for detailed data. There is certainly, we have built-in downsampling for being able to downsample your data, right? One of the things you can do with Flux that's really cool is that I can use Flux as a, for alerts and notifications, right? And so something happens in my data, and I get an alert about it. And one of the things that alert can do is run another Flux script. So I can then say, this alert happened. The CO2 content went above 5,000 parts per million. And that was an alert. And so what I'm now going to do is I'm going to go back and I'm going to get 10 minutes worth of data leading up to that event. And I'm also going to collect data for the next 10 minutes, and I'm going to send that 20 minutes of data along with the event upstream. Because often there's more to just the event happening, right? Yes, event happened, but what caused the event? I don't know, right? That's what data's for, to tell me what happened that caused that event. So when the event happens, I can trigger a script that can go get all the data leading up to that event and write it upstream.
And if you had a distributed data collection model, where would that be? Would that actually be in an Influx engine in that WRT router or Pi or?
That depends. The answer is always it depends, right? Stock answer. I can answer every question with it depends. So let's say I'm running an ARM system at the edge that's collecting data, and it's giving my local user a dashboard, and it's doing alerts and notifications for that local amount of data, right? But I don't want to send all that data back upstream because that costs money on the network, right? So I'm downsampling the data. And I'm doing, say, rolling 5-minute averages of all the data. And I'm sending the 5-minute averages upstream, right? When an event happens, I can go back and I can get 10 minutes worth of full granularity data. And I can send all of that back upstream, right? So when an event happens, screw the budget. I'm blasting it up the network no matter what it costs because I want to know what led up to the event, right? And I can set different retention policies on my data. So the edge collection device may have a 30-day retention policy, right? Because I'm dealing with my data in real time. I don't care what happened 6 months ago at the edge. We're past that now, right? That already happened, right? The building's on fire by then. Don't care, right? Doesn't do me any good. So I have a 30-day retention policy, but I'm running 5-minute rolling averages back upstream. And those 5-minute rolling averages I want to keep for 6 months because it's important to me to sort of have a flavor of what was going on in that location over the last 6 months, right? And I'm going to do a 20-minute rolling averages of that data back upstream, and I'm going to save that data forever. So I have historical data, but I don't necessarily need to know down to the millisecond what was going on. But I can take those events and that data around those events, and I can write that to a measurement upstream that never goes away because events are important and the data surrounding events are important so that I can do forensic analysis on that event. And I may have reporting requirements. I'm a nuclear reactor and I've got to be able to answer for every single event, right? And I've got to be able to answer for every event for the last 10 years. So I'm going to save those events and the data around those events for 10 years. But it's only sort of 10 minutes worth of data per event. So it's not a huge amount of data. I can do that.
Right, taking care of the 99% of normal.
Right. And I have the overall flavor of everything that's been going on from my downsampled events, right? And if I really don't care about what happened more than a year ago, then I can just throw everything away that's more than a year ago. And one of the things that you do with InfluxDB is you set data retention policies on the data. So you say, I'm only interested in having this data for 30 days. And so when we move from one shard to another, when we take this data shard and it's now cold because we're not writing to it and we're not reading from it anymore, and we're compacting that, and as the database is compacting that shard, it looks and it says all that data is more than 30 days old, and my retention policy is 30 days. Well, I'm not going to bother compacting, I'm just going to throw it away. But I'm going to write something that's called a tombstone to let you so that I know I threw that away, right? So that you can, if you query that data, I'll say, nope, we threw that away outside the retention policy, no longer here, right? As opposed to, what are you talking about? We never heard of it, right? So we still have a record of, yes, we knew about that, but you didn't care anymore, so we threw it away. It's not my fault, it's yours, right? Yes?
So you're maintaining a tombstone for each record that's been deleted?
Not for each record, for each shard. So a shard may contain, 60 days worth of data, right? And I have a 120-day data retention policy. And this 60 days worth of data is more than 120 days old. So I'm going to throw it all away and write a tombstone that 60 days worth of data is gone because you didn't want it anymore.
Thank you.
Yeah. So it's not per record, it's per shard in the database. And so it actually matters at some point when you really want to get down to it, thinking about what your data retention policies are and your shard size, right? Because if you have a 30-day retention policy, but your shard holds 6 months worth of data, then effectively you have a 6-month retention policy. Right? And if you're doing something on like a Raspberry Pi, where its storage is a memory card that suffers from read-write wear, then you want to be aware of how often you're writing the data, right? And I'm writing the data, and then I have to copy it over here and write a shard, and then I have to erase that shard and write, and so I'm causing wear on that SSD card. And so you want to look at your data retention policies and the sizes of your shard to make sure that you're not causing excess wear on those things. I have only run into this problem once. I had been running a Pine 64 with a 64 gig memory card, and I paid zero attention to my shard size, and I set my data retention policy to infinite. And about a year into collecting data on this device, it suddenly got into an out-of-memory loop where it would start up and it would start to compact a shard, and it would run out of memory and it would crash. And it would start up and say, oh, I need to compact the shard, and in the middle of compacting the shard, run out of memory and crash. And this went on forever. So the only thing I could do was to blow away all the data and start over. Because basically my shards were so big that I didn't have enough RAM to run the database and compact the shard at the same time. So, lesson learned. Luckily, it was not data that I was interested in. If it had been, what I probably would have done was move all those shards to a different machine and start that instance up, pointed at that data, and let it deal with that, and fixed it later on the other machine. Yes?
Yeah, kind of mentioned the same thing. I was wondering for the older shard, passing the retention policy, do you have the ability to move the old shard to an offline storage or different machine for archiving purpose?
You can, yes. However, you run into the problem that since I didn't delete the shard and write a tombstone, the database will still think it can get to that shard. And you go query that cold data, and it's suddenly not there anymore, but there's no tombstone saying it's not there anymore, right? So the difference between just moving the shard out from under the database and having the database expire the data and write a tombstone is that a tombstone, it tells the database, I know that the data's not there anymore. It's not there anymore because you told me you didn't want it, so I deleted it, versus what happened, right? I'm looking for it, it's supposed to be there. And I'm going to get errors because it's looking for something that it thinks is there, but I moved it because it was a cold shard and I didn't tell anybody, right?
By the way, what's tombstone mean?
A tombstone basically is just a flag that I set that says,
okay.
This data's dead,
Okay.
right?
Definitely, okay.
Here lies your old data. You didn't care anymore, so I have killed it and buried it here, and you can't have it.
But we should have ability to update the reference key of the tombstone, right? So that the database knows that this old shard has been moved to offline storage.
What I would suggest doing is using some of the backup and restore capability of the database to actually write that as a backup, right? So before you have the data expired, you write the data to a backup that is in a different location, and then you expire the data locally so that the database locally knows that it no longer exists. But you know that I have backups of it, and should I need to, I can re-import those backups and have that data again. I believe we're out of time.
Yep.
Yeah. I really appreciate everybody being here and asking so many awesome questions. This was a lot of fun. I much prefer this to murdering you all with PowerPoint and boredom. So thanks so much for coming. This was awesome.
Awesome. Thank you, David. don't forget, next month, November 5th, we're going to meet at Inventus, and it's all about consumer IoT and a whole bunch of really great lightning talks, so please come to that.